Much research is done in support of smallholder farmers in developing countries, and it's long been recognized that the environments and the people living in those places tend to be very heterogeneous. And a recent trend in research is the recognition that this heterogeneity really matters, and that technologies that are widely adapted to many situations are probably rather rare. In this short video, I explain a way of conceptualizing this, which we found to be useful. I'll introduce it here and explain how it can be used in further videos. We start by looking at an idea that crop breeders have long recognized and exploited, the idea of genotype by environment interaction. It's illustrated here with a simple example of comparing two crop varieties, just labeled A and B, across a range of environments with varying drought stress. As stress increases, the yield of the crops decreases, and that's not surprising. But the way that the two varieties respond to increasing drought stress is not the same. Variety A starts off with a high yield in low drought stress environments, and that is reduced quite quickly as stress increases. Variety B reduces less quickly as stress increases. So the difference between the two varieties is much larger in the low stress environment than in the high stress environment. Hence the two lines on the graph are not parallel, and we say that there is an interaction, a genotype by environment interaction. If we look at a wider range of stress, then it is possible that these responses actually cross over, sometimes described as a crossover interaction. And now, if you're a researcher trying to find the best variety to use, then you have a problem, because the best is not the same in different places. We might identify three different types of environment. There are those low stress environments where A is clearly superior. There are those high stress environments where B is superior, and there are some around the middle where it doesn't really matter which of the two. A variety like C would be highly desirable. It's good everywhere, and it's relatively stable. Its yield does not decline so much when drought increases. But such things rarely exist. Things which are stable across many environments are typically more like as represented in this diagram, and then we still have these choices as to whether we are looking for single varieties which are not too bad everywhere, or whether we're looking for things that exploit the potential of different environments, like variety A does in the low drought stress environments here. Now, there is much more to genotype by environment interaction than I've presented there, but what I want to do now is to show how this concept generalizes. Agricultural researchers don't just develop varieties. There are a huge range of other components of agricultural systems which are researched and new alternatives devised. For example, soil management. You have to grow the crops in some soil, and the way we manage the soil matters, and so agronomists look at the way soil can be best managed to increase productivity and increase sustainability, perhaps. It's not just management of soil. We might develop whole agronomic packages where we look at integrations of things like soil management, planting time, pest management, and so on. The work continues after the work in the field, post-harvest research, looking at things such as alternative storage methods. The same thing is true when we go beyond just dealing with crops or indeed animals, but start putting people into the systems. Researchers are also looking at alternatives such as different approaches to training farmers, or different organizational models by which farmers and components of the value chain might be organized. So rather than just comparing genotypes, we think much more broadly of the options that might be compared in a research project. When plant breeders talk about environment, they're typically meaning the climate and the soil. But again, there are many components of environment which are important. Studies recently have emphasized the importance of farm resource endowment as a variable that distinguishes or separates farmers into groups that have different objectives and different requirements, and they tend to value some of these options which are being offered in different ways. The level of market integration of farmers is something else which determines what they're interested in and what they're able to use. We could look at more obvious social variables like gender or the household type or even ethnic group as components of the social environment which will interact with the options. So rather than just describing environment, we use the term context to describe the broad social, economic and ecological environment. And finally, we can think more broadly than just about production. Farmers and people looking at farm systems aren't just interested in production, they're interested in other variables like risk, like profitability, or some general notion of what is acceptable. And they might be interested in outcomes beyond the farm, such as impacts on nutrition. So we describe these as performance. So rather than just thinking about genotype by environment interaction and the way that that determines production, we think more broadly of option by context interaction and the way that that determines performance of the farming systems. And the ideas which we've described on the previous slide in relation to genotype by environment are equally relevant here. Research and development systems embrace many different styles of participation of farmers and participation of other players. This option by context interaction concept is relevant whatever style of participation you are using in your research. And likewise, it is relevant whether you are thinking about quantitative methods or qualitative methods or mixed methods. And the reason it's relevant is because there are common principles that underlie how we should do research to discover and understand option by context interaction. So, what next? In further videos, we will explore two things: how the idea of option by context interaction can help us design improved research, and how we can actually build on more concepts from breeders to do research effectively.